Okay, good morning, students. In this lecture, we are going to discuss about the CMOS. CMOS is complementary metal oxide semiconductor technology for designing the gates and electronic devices. Right now, here you see this one. We are having the fundamental devices. We are having P channel device and the N channel. Right. So what it is actually we are having now. We are having source, drain, and we are having base. Right. So we are having now this is the in that case, right? I will draw the diagram now. You consider now this is the one device, right? This is a P channel, right? So that P channel, okay. So this is the P channel. Now in that channel we are having now three end, right? So source, drain, and here we are having now base. Now we are applying that zero here, right? Zero means it is connected with the earth. Zero is here, zero is we are having now. If it is zero, then this P channel is allowed to conduct to source to drain, right? So here if you are applying zero voltage on the base, right? Now the P channel start to conduct means then we are having a connection. Okay. If you are applying that one, now the channel is closed, then it will stop, right? So this is the basic for P channel. Now in that N channel, so this is the N channel. Okay. Here, if you are applying one, now the N channel allowed to conduct. N channel allowed to conduct. If you are applying one, right? N channel allowed to conduct means then here we are having a conduction. So this is open, right? If you are applying zero, then this channel is closed, right? Channel is closed means it won't conduct, right? So now the basic device using CMOS is we are having now NAND, NOR, and inverter. The basic device by the CMOS technology is inverter, NAND gate, and NOR gate. So in that inverter, you see this one. Here inverter is if you are applying one, then we are getting the output is inverter. So zero, A dash. Then how we are zero means is connected with ground, right? Now if you are applying one, then the N channel allowed to conduct. So it is directly connect with ground. Now here both are same, right? Here one, then it won't allow. So our output is connected with ground. So that is ground is zero. So we are getting now zero. Now if you are applying that voltage, applying zero, right? If you are applying zero, then we should get one. This is the inverter characteristics, right? Now how it you are applying zero. Now the P channel allowed to conduct. Now this line is connect with VCC, VDD, right? So we are having now that VDD is here. We are getting now this VDD is directly connected means we are having now the voltage 5 voltage. The 5 voltage is equal to 1. If you are connecting with ground, it is 0. Connecting with ground is 0. Applying connecting with VDD, we are having value 1. Right? So, in that inverter, what you have to write? So, we consider now, if you are applying A equal to 1, if apply A equal to 1, now the N channel is open. A equal to 1, then N channel is open, then Y is connected to the ground, then we are getting now 0. If you are applying 0, A equal to 0, P channel is open, applying 0, the P channel is open and it connect with VCC. So connected to VCC. If connected to VCC, then here we are having that value 1, y equal to 1, right? So connecting value y equal to 1. So this is the case, y equal to 1. Here we are having now a equal to 1, then y equal to 0. So you have to write this, if they want to ask that, explain about that inverter in CMOS technology. So inverter is going to be designed by one P channel, one N channel connect serially, and in the mid you have to take it out, and here the base is connected and connected with input. So input is base, common base for both P channel and N channel. Then P channel is connected with VCC. The N channel is connected with ground. Then the output is in the mid you take now. So this is the design of inverter using CMOS technology. Now here for NAND gate. In the NAND gate, now how do you do that one? We have to connect two P channel parallelly. P channel parallelly, P channel device parallelly. Right? Now here we are having now NAND. NAND is the output is, if you are having A and B, then AND is AB and NAND is AB dash. So the characteristics is, if you are applying both 0, now overall is 0 and inverted, so we are getting now that value is 1 as output. So if you are applying both 0, at a time if you are applying both 0, this y is connected with VDD. Y is, we are getting now 0, 0, that 1. Y should be 1. The result should be 1. Then how do you get now? If you are applying 0, here we are having now applying 0, 0 on both, or otherwise here 0, 0 on both, or otherwise any one of that one is 1, right? So A is 1 and B is 0, or A is 1, B is 1, right? Then if you are having that 1, 1, then it will make 1, 0, 1, 0, 1, sorry. Okay, okay. Well, sorry, is something wrong. Okay. Here and right. So here, if you are having that 0, both are 1, then only you will get now 0. Both are 1, you will get now 0. How it is? If you are applying 1, then N channel is open. So N1 is open and N2 is open. So at a time A should be 1 and B should be 1. Then only you will get now the output is 0. All other possibility, the output is 1. All other possibility is the output is 1, right? So what you mean by that one as, if you apply that A1 and B1, at that time the Y is connected to the ground. So here we are having two N channel connected serially. So you have to apply both one, then only your output is connected with ground. So both are 1, then N channel is open, the N channel, two N channel serially connected N channel is open, then it is connected with ground. So the condition is, if both are 1, so AB 1, then we are getting result 1, then inverted, you are getting now the result is 0. This is the NAND gate property, right? So the NAND gate property is, if you are applying 0, 1, then we are getting now that 1, then the output is 0. If you are applying that 0, 0, the 0, the here output is 0, 0, the 0, 1, right? If you are applying that 1, 0, then we are having that 1, 0, 0, the output is, right? So 1, 0, the output is 0, 0, then output is 1, right? Then here, correct now. If applying both 0, the 0, the output is 1. Then if you are applying that 0 or 1, then we are getting now the result is 0, then 1. Result 0, then 1, right? Then this is here we are coming as this result is 0, 1, right? If you are applying both 1, the result is 0, then we are getting now 0. So that is, the result is 1, 1, 1, then inverted 0, right? So this, the result is 0. So and this, the result is 0, the result is 0, then inverted, we are getting now that all are 1, right? Then here, so here the condition is, if both are 1, then the result is 0. So if you are both are 1, then two N channel is open, both are one, right? So here A1 and B1, then both N channel is open, it's connected with ground. So 1 is going to have as a 0, right? Then all other cases, then here 0 1 and 0 0 and 1 0, right? So at the time that 0, this channel, one channel is closed. So wherever we are having 0, n channel is closed, then the 0 is applied in parallel P1 or P2. If you are applying P1 0, the P1 is open, then our input is connected with voltage. Or otherwise, if you are applying the B is 1, then this is connected with that. It's a parallel. So at any one is 1, then it is connected with, or any one is 0. Any one is 0, then it is connected with, then we are getting now the result is 1. So this is the result. So any one is 0 or both 0, then the VDD is connected with by P1 or connected with P2 or connected with both to the VCC VDD. So we are getting now that output is 1. That is NAND gate. Right? If both are 1, then this two NAND gate is connected with ground. All other cases, then any one of the P channel or both channel is, if we are applying that this 3, right? 0 1 or 1 0 or 0 0, in that these 3 cases, 0 1 is here, P2 is open. So this is connected to VCC, we are getting now 1. Here A is 1, then A is 1, then here A is 0, then here we are getting now this P2 is open, then A is, sorry, this is A, sorry, here, now here A is 0, A 0, so applying that A 0, P2 is open, then this is connected and we are getting now 1. Then if you are applying that once here that 0, then 0, that B is open, then this is connected with ground. They are connected with VCC. So we are getting now that voltage 1, right? If both are 0 0, then P1 is open and P2 is open. As well as both are connected with that VDD, we are getting now that VDD as 1. So we are getting now 1. If both are 1 1, then here the P is closed, P1 and P2 is closed, then N is open and N2 is open. Now this is connected with ground. So that is we are getting now 0. Right. Then we are coming NOR gate. How do you design an NOR gate is, you have to connect N channel as parallel in the bottom. Right, in the bottom we have to connect N channel, then it is connected with parallel. Parallel means here we are having, this is the parallel connection, right? So this is parallel and this also parallel. So both are connected in parallel, right? So the N1 and N2 connected on the bottom parallel, and you have to take output, right? Then we are having P1 and P2 is connected with the series from VDD. Then this output is connected with here, right? Now in that circuit is a NOR gate, right? So the NOR gate characteristic is A, B, right? So for OR gate, what it is? And inverted is NOR, right? So A1 and A0, B0. Both are 0. We are having R is 0, right? So then we are getting NOR gate is 1. Here we are having now 1 0. The R is here, R0, R is 1. Then inverted is 0. Then here we are having now 0. You are getting now that here we are having now R. So this is 1. The output is 0. Right? Then here we are having now 1 1. Then R is 1. The output is 0. NOR gate. Right? It's an R. So NOR is here. Right? So is it is a condition. If both are 0, we are getting now 1. Right? Now If A0 and B0, A0 and B0. Right. A0 and B0. Here A0 and B0, then this N1 and N2 is closed. Then the 0 is connected here, right? So now this is connected with power supply. If it is 0, it is 0. It is connected with power supply, right? If it is 0, it is 0. Connected with power supply, you are getting now 1. Then here anyone is 1, right? If you are applying 1 in P channel, the P channel is closed. So at least one is there, then one channel is closed, then directly the VDD, right? Any one of the channel is closed or both is closed. We are cut. We are we couldn't get anything from VDD. So here N1 is open, or otherwise N2 is open, or both are open. Then it is connected with ground. So that is here 0 0 0. The connected with ground is 0. Right? So we are getting now this is the corresponding output, right? They may ask that explain the operation of the NOR gate and NAND gate, right? Now you want to get AND gate. How we are getting that AND gate is you have to connect NAND gate concatenate with one NOT gate, right? So this is the NAND gate. Then this NAND gate is connected the concatenation of inverter. Concatenation of inverter. So NAND through NAND gate AB dash. Then is inverting, we are getting now AB. So Y equal to AB is AND gate. So the operation is here, right? So this is here we are having now that this is the AND gate. So inverting that one. So whatever here, if it is 0, it is 1. Or if it is 1, it is 0. So this is we are having that inverting. So NAND concurrent with the inverter, we can design AND. So they may ask question about that. How do you draw the AND gate? How do you design AND gate through CMOS? CMOS technology, right? So directly we can have now one NAND gate and one inverter. So one NAND gate and one inverter is connected parallelly, concatenated. Then you will get now AND gate. Similarly, for OR gate, you are having OR gate. You connect the NOR gate, right? So NOR gate is basic gate for CMOS. Then we are having inverter gate, right? Then you will get now OR gate. We cannot directly design the AND and OR, right? So directly design NAND and NOR and inverter. So how do you design that AND gate is the NAND gate concatenate with inverter, you can design AND gate. Similarly, here NOR gate concatenate with one inverter, then we are having now OR gate. So we know that one. How do you execute inverter and NAND NOR gate, right? Then this is a concatenation. You have to explain that one, right? So this is a way of explanation about that CMOS technology. Using CMOS technology, how to design AND gate. Using CMOS technology, how to design OR gate, right? So here we are having inverter and NAND gate is basic, and NOR, inverter NAND NOR basic. Then you can design that one NAND concatenate with the inverter. It will form AND gate. Then NOR concatenate with inverter, you will get now OR gate. So this is a way of designing the AND gate and OR gate using CMOS technology.